Hi everybody, I'm going to record, it's Ajanette, your instructor, and I'm going to go ahead and record your Chapter 1 lecture through Zoom. So I'm just going to share my screen and then I will open up that PowerPoint. And sometimes Zoom has a little bit of challenge where I'm actually in presentation view while I'm in a Zoom. So I'm just going to go ahead and leave it like this so that you can still see and clearly, but it won't interfere with the Zoom. So that being said, Chapter 1 is going to be your first introduction. It's in a module all on its own. So we're going to take a slow start into statistics, but then we're going to really dive in and start going very quickly, sometimes covering 4 chapters in a week. So be prepared for that, okay? This first week, we're going to deal with all of the introductory activities and the first chapter, and then next week we'll be really busy. So that being said, let's talk a little bit about statistics. So a lot of us kind of come to this class with some kind of understanding of what stats is. And often we think of it as a math class. And we think of all the statistics out there in the world, like coronavirus statistics and what percentage of the population has it. And of those that have been diagnosed, what percentage are African-American or Hispanic or any other ethnicity. We might think about median income levels, and we can also look at racial disparities in median income levels and see that we have even educated African-American individuals make significantly less and have lower income levels, and they have lower rates of home ownership, and there's this huge wealth gap. We can talk about the statistics about what percentage of the people own 90% of the wealth in the company or in the country. And so, you know, statistics are often those facts and figures. Something more lighthearted, you might think of them as they relate to sports, right? So when we're typically thinking of the traditional notion and definition of statistics, we think of those facts and figures. We think of these numbers that kind of condense a whole lot of information and summarize it into just 1 or 2 very informative figures. And that is in fact accurate, but we're going to move beyond kind of our basic understanding of statistics from a mathematical standpoint. And we're going to reconceptualize statistics as a research methods class. And our formal definition of statistics is its mathematical procedures that allow us not only to organize and summarize information as you are most familiar with, but it also allows us to interpret information. We're going to use inferential statistics, and we'll talk about that in just a second, to draw conclusions about the world, to answer our research questions, to come in and statistically analyze the world around us in a methodical way that allows us to answer questions based on empirical evidence and not just opinion, conjecture, or personal experiences. So the reason that our general purposes for using statistics is in fact to help researchers answer questions. And that's why I want you to reconceptualize statistics for the purposes of this class. It's really not going to be taught as a math class. It's going to be taught as a research methods class. And so you will be always looking at these mathematical techniques in the context of research studies. And under what circumstances, based on what type of question we're asking, what type of data are we working with, under what circumstances do we use what technique? How does that technique allow researchers control over the study and allow us to control and minimize error? And so we'll talk about that throughout the course. And then additionally, we do in fact use statistics to organize and summarize information. And I want to be able to clearly show my audience what the research is saying. And so I want to be able to present it in a clear, coherent way. And so statistics are definitely going to be utilized for that as well. Let's talk about the difference between a population and a sample. So when we talk about a population, truly that's all of the people that we're trying to understand. We're as social scientists, we're looking at behavior, right? And we want to say, well, I should say as psychologists, we look at the study of human behavior, the scientific study of human behavior and the brain. And so we definitely want to, when we're looking at behavior for overall populations, right? But realistically, we do not have the economic means or even the time to be able to gather data from every single person in the population. So if I want to understand how teens view social justice differently than older generations, I can't possibly survey or study every single teen in the US or every single older individual in the US. So what I do is I gather a sample of teens and a sample of maybe young adults and a sample of middle adulthood and a sample of late adulthood. And I want to kind of compare the differences in their views of social justice and equality between the different age groups. So I start out with a population, I'm trying to understand how teens compare to other generations in terms of their social justice views. That's my population. But when I look at realistically who can I gather data from, that's going to be a sample. It's going to be a subset. So think about like 31 Flavors ice cream. I'm a huge ice cream fan. I use it as a treat and a reward. I also use it just as a means of consolation when I'm having a hard day or stress management, which probably isn't healthy, but it is something I do. But when I go to 31 Flavors and they have a new flavor of the month, or I did before everything happened, I didn't need to eat the whole 5-gallon drum of ice cream to know what it tasted like. Instead, they gave me a sample, right? And on that sample, I was able to make inferences about the larger 5-gallon drum of ice cream. I was able to infer what it tasted like based on my sample. And so that's what we do in research. We use samples, and it's a small subset, right? It's a reasonable amount of people that I can ask questions of, I can gather data from, and then that allows me then to draw conclusions about the larger population. And so what we want to pay attention to, though, is we need to make sure our sample is in fact representative of the larger population. If in that 5-gallon drum I have Rocky Road, but on my sample, I think those spoons are entirely too small, but on my sample, I only have an almond. Does that really give me a good idea what the Rocky Road tastes like? No, right? Or if I only have a marshmallow, or if I only have chocolate ice cream, if I leave out the key ingredients from my sample, I'm drawing in erroneous conclusions about my population or inferences about my population. So that's a problem. So what I want to do is I want to make sure when I am sampling, right, the sampling is the method by which we gather that subset, that sample from the larger population. If I'm using effective methodology, which will be studied in a research methods class, then I know that my sample is going to be more representative. I need to make sure my methodology leads to a representative sample. And it doesn't. And here's a problem in the field of psychology in particular. Most of our research over the years has been conducted on college students who historically were white males. And over the years, it's evolved. And we do actually now statistically have more females in college than we do males. We actually have more females graduating from college than males now, but they are still predominantly white. So a lot of our research in psychology that drives how we view the world and how we explain human behavior is based on that of white individuals. And when we look at a population that is overwhelmingly, particularly in California, diverse, then we might be drawing erroneous conclusions. We may not be allowing for the cultural differences and the individual diversity. Let's take gender, for example. We study most of our research from a binary lens, and we have research from cisgender males and cisgender females, and we do not explore how individuals that are non-binary or other gender identities may in fact view the world differently, or they may be experiencing the world differently or experiencing different levels, certainly of discrimination, of hate, And so it's important for us as researchers as we move forward that we're very intentional about our sampling and we're very intentional about understanding the diversity of the population so our samples can in fact reflect that diversity. But overall, the population is that larger subset of individuals we're looking to explore. So when we also do research, we focus in on what we call variables, right? And the variable is our point of interest. That's what we want to study. It's a characteristic or a condition that can change or vary from person to person. So across individuals, let's talk about something as simple as height, right? We're not all the same height. We all vary. Some of us vary slightly from one another. Some of us vary hugely from one another. But height is something that can differ from individual to individual. A preference for ice cream can differ from individual to individual. One is something that is just a fact about me, my height, so it's a participant variable, and one is something that is really about my behavior. It's not something, you know, that you guys, you know, can control, but it's just my preference of ice cream, right? That being said, when we talk about variables, we are trying to investigate how variables differ between groups or how variables can be manipulated to show us how that might impact differences in other variables between groups. So variables can be either manipulated, and by manipulated, we're not talking about how we manipulate people emotionally like an X might do, right? We're talking about manipulating a variable as a means of assigning people to groups and determining how much of the variable they're exposed to, when they're exposed to it, how many groups that are exposed to it. So we use it as a means of grouping or differentiating between people. Measured variables are just that. We just measure them, right? So if I want to look at social justice views across age groups, my manipulated variable is going to be age. And although I'm not directly controlling age, I am determining as the researcher what my age groups are going to be. So I'm determining that I'm going to look at teens compared to early adulthood, compared to middle adulthood, compared to late adulthood. That's how I am manipulating that variable as a researcher. Someone else might say, I'm going to look at people 15 to 18. I'm going to look at some people from 19 to 21. I'm going to look at people from 22 to 24. So it's all, we might all do it differently, but we are determining the categories that define our groups in that research study. And that's what we mean by manipulation. Measured, I am just going to, after they're in their groups, I'm just going to ask them their views on social justice, racial equality, LGBTQ rights, women's rights, immigrant rights. I'm going to ask them a series of questions to determine whether or not we see younger individuals being more supportive of social justice issues. And actually, spoiler alert, that is in fact the case. Research shows that there is a large generational divide, and older individuals who sadly are more likely to be in positions of control and leadership, including the presidency and congressional and Senate positions, are older, and often older white males that may no longer represent the general views of society, and most commonly do not often represent the views of younger society. So just a spoiler alert. Another thing you need to consider when we're looking at variables and data is kind of the terminology that we use. Datum is terminology that's used to represent a single score. So if in a study we're measuring height and we're looking at the height of our class and how that compares to the height of the college at large, my single height score, so the measurement you get for my height, which is 5'9", is what we call a datum. But then we're going to measure everybody's height in the class. And the collection of heights, of scores for heights, is what we call data, plural, data, or data set, okay? So keep in mind, we do apply that terminology differently. So Let's talk also about terminology that corresponds to data. Remember, we differentiated between a population and a sample. And a population is a larger group we're really trying to draw conclusions about. But they're so large, there's so many of them, it's unrealistic to gather information from all of them. So instead, we are focused on our sample and gather data from our sample. Well, we have statistics that correspond to the population, and we have statistics that correspond to the sample. We call those two different things. Parameters are P, they correspond to population. Statistics are S, they correspond to samples. So parameter for population, P for P, and S for S, statistic for sample, okay? And we typically, when we're talking about mathematical notation, we represent parameters through uppercase letters, and we represent, or Greek letters quite often, and we represent statistics through lowercase letters. When we are talking about statistics, we're going to differentiate in this class between descriptive statistics and inferential statistics. You're going to do both. All the time throughout the class, every technique will involve both. We're really not going to get into inferential statistics until module 3, but we are in fact going to do both. Descriptive statistics serve a different function than inferential statistics. And I want you to just focus on the root word, okay? Because that tells us a lot. Psychology is pretty good about that too. If you kind of look at the root word, it gives you a lot of insight. But definitely the way we've termed these things. And this isn't psychology, this is just overall great mathematicians, right? Descriptive statistics describe the data. They tell us what's happening. They're simple techniques that are used to kind of simplify and summarize what the data is telling us. You're going to learn about two types of descriptive statistics, measures of central tendency and measures of variability. And you're going to learn that in the next module. Measures of central tendency tell us how similar data points are to one another, and measures of variability tell us how different they are from one another. And what they do is they gather the raw scores, and then they do calculations and manipulations of that data, and they come up with a key figure. The one that you're most familiar with is mean. It's just an average, right? So we might look at the average height for our class. The raw score is my individual height and my neighbor's individual height and their height and then the next person's height. And then the measure of central tendency, or the mean, is looking at calculating all of those scores. So we add them all together and divide by the total number of scores, and that's our average. That mean now is a single score that represents how similar we all are in height, okay? We're also going to study measures of variability that'll come up to tell us how different we are too, like variance, standard deviation, range. Now, inferential statistics rely on descriptive statistics, but they serve a different purpose. Their purpose at the root word is inferences. Remember, we started out by talking about a population and a sample, and we're gathering information from our sample to make inferences about the population. If my sample is in fact representative and I see patterns emerging in my sample and my sample's large enough, right, then I can validly infer that those same patterns are likely going to emerge in my larger population. So what we need to do is we need to do the mathematical calculations and techniques to determine whether or not statistically it meets a threshold of what we call significance. And if it is in fact significant, then that allows us to say, yes, there is something distinct, inherently unique about our particular independent variable study. And so yes, in fact, our drug worked, or yes, in fact, there are differences based on age in social justice views, okay? So our inferential techniques are techniques that are used to draw inferences about the population based on the sample. They focus on statistically analyzing differences between groups to see if it reaches a threshold of significance. And if it does, then I can say, yes, there are significant differences in social justice views across my groups based on age. So age, in fact, is a factor contributing to the differences. So we're going to learn a number of techniques. We're going to learn about z-scores, 3 different t-tests, analysis of variance, or ANOVA, also sometimes called an f-test. We're going to learn about correlations. We're going to learn about chi-square analyses and a little bit about regression analyses. So you're going to learn multiple techniques over this course. And ideally, as you're reading empirical research and doing empirical studies in other classes, and definitely doing your own research and research methods, you're going to see that this class will lay a groundwork and foundation for you to better understand those studies that you're reviewing. Okay, so let's move on. Now, what I do in our classes, as you're going to see, is I build in learning checks. And so I'm going to go through a certain amount of information and content, and then you're going to do a learning check. And we're coming upon that. So we just need to cover one more concept, and then we're going to do a learning check. Sampling error. Remember, if we're looking at height and we're looking at how our class differs from the population, we know that on average, the average female is 5'7". I think the average male is 5'10". So if we're looking at measuring everybody in our class, and how does our average height differ from the population height? Well, interesting, you're going to find that if you do our class and the class next to us and the class next to us, each one's going to be slightly different from the population. We're never going to be exactly the same as the population. Each sample is going to be slightly different. That's okay, right? That natural occurring difference between the sample and the population is what we call sampling error. But we want to make sure, because just like any variable, we know not only can things vary from person to person, they can vary from group to group. And sampling error represents that variance from group to group. What we want to make sure is, though, that you're not working with a sample that varies beyond what's reasonable from the population. And that's why statistics are important, because we mathematically control for that sampling error, and we try to make sure that the error is still within reason, okay? So now, as I mentioned, we're going to do some learning checks. And so what I want you to consider doing is take out a sheet of paper and actually pause the video, read through the learning check, and answer the questions. So challenge yourself. We know learning theory and memory theory talks about elaborative rehearsal, and the deeper we dig into the information and the more we rumble with the information directly, and instead of just passively listening to these lectures and even taking notes definitely helps, but even taking notes is still somewhat passive. I want to turn it into an active lecture experience where now you're trying to actively apply what we just learned in this section. So all the terminology that we just learned, population, sample, parameter, statistics, sampling error, inferential techniques, and descriptive techniques, variable. I want you to think about those things, and I want you to now apply what we just learned into the learning check. So pause me and then go ahead, and when you're ready, when you have rumbled and you have your answers, right or wrong, then start me up again. We're going to move on and we're going to show you the answers. So when we're talking about a researcher interested in the texting habits of high school students in the US, the researchers measures the number of texting messages that each individual sends each day and calculates the average number for the entire group of high school students. When we're talking about the researcher interested in texting habits of high school students in the US, that's our population. It's unrealistic I'm going to be able to study every single high school student in the US. I can't even study everyone in California or even everyone in San Diego County or Riverside County, right? So that's really important. What variable are we interested in studying? What is it that the study is interested in exploring? It wants to understand texting behavior. So our variable is looking at the number of text messages being sent. When we talk about that average number for the entire group, because it's a statistic that corresponds to a population, it's P population, P parameter. So it's a parameter. When we're talking about datum, that's singular. It's one raw score. So it might be looking at, Jose's texting behaviors. What are all the numbers you collect on all the numbers that you collect on the texting behavior? That's what we call data, plural, everybody's information. And we also call that a data set. So we have another learning check. Again, pause, and then just read it, go through, answer the questions. I'm gonna go ahead and move on, but you pause. Okay, so assuming you now have your answers, a researcher is interested in how watching a reality television show featuring fashion models influences the eating behavior of 13-year-old girls. So ask yourself, who am I studying, right? I'm studying 13-year-old girls. My population is I want to draw conclusions or learn and understand the behavior of 13-year-old girls. What else am I studying? I'm studying how watching reality television with fashion models, right? So it's a specific type of reality television influences eating behavior. So when you look at number one, a group of 30, 13-year-old girls is selected to participate in the study. It's now a subset. So that 30 girls becomes my sample. In the same study, the amount of food eaten in one day is measured for each girl, and the researcher computes the average score for the entire 30 girls. The average score, it's corresponding to the sample of 30 girls, and so it's a statistic. What are my variables for the research question? Two things, right? I'm looking at the type of reality show watched. Specifically, how does maybe fashion model reality compare to non-fashion model? And I'm looking at their eating behavior. And what is the population for this study? It's all 13-year-old girls, okay? So we are gonna have one more, are we? I think we're gonna have one more learning check. And so again, pause, write out your answers, and then when you're ready, turn me back to play. Okay, so here we go. Statistical techniques are classified into two categories, right? Descriptive statistics that describe, inferential statistics that allow researchers to draw inferences about the population based on the sample and to answer their research questions. And then sampling error is that natural discrepancy that occurs from a sample to a population and how samples vary from one another. Okay, so what I'm going to encourage you to do, research shows that when we're studying memory, memory is actually better if you take breaks. If you study things in one long segment, like we do when we're cramming for a test, it actually isn't good for memory. We might be able to regurgitate that information and do well on a test, but in terms of truly retaining it for long periods, it doesn't do well. Research actually shows it doesn't improve scores for a short-term test either, so just so you know. Instead, distributed practice is more effective, and so that's when you study a little bit at a time and you break up and you chunk up your information. We have good memory for what we first started talking about and good memory for what we're last talking about, but we lose a lot of what's in between. So I'm going to encourage you to chunk up the lecture. I'm going to keep going, but you might want to stop. After each learning chat, go take a break, stretch a little bit, do just a quick mental break, even if it just means doing some breathing, some relaxation techniques, maybe checking your messages on your phone. Take a break, okay? But I'm going to keep going and keep everything in one lecture. Okay, so let's talk now about two types of structures for how we can examine statistical relationships between variables. We can compare groups, right, where we break things into groups, such as our example of talking about different age groups and looking at how their social justice views differ between teens, early adulthood, middle adulthood, late adulthood. okay? That's what we call a comparison model. We can also use a correlational model where we just have one group and I'm focused on the variables. I'm not looking at differences between groups, I'm focusing on the variables. But, you know, study 500 people and I measure their age and I measure their social justice views. And then I look at the relationship between those two views. And we do in fact find that as people are younger people have more proactive social justice views. That's what we call an inverse correlation or a negative correlation. But it's still one group and I'm comparing the variables to one another. As opposed to the comparison model where I've broken participants into groups and now I'm looking at average social justice ratings and how they differ from one another. And notice I'm not doing any averages for the correlational method, right? I'm just looking at how does social justice, so as I see age changing, how is the social justice changing along with that? One is correlational where I'm only working with measured variables. The other one is a comparison model where I'm working with a manipulated variable that I use to break people up into groups. And I'm also working with a measured variable, and it's the measured variable I'm comparing between the two groups. Okay, so let's go a little bit more into the correlational method. Again, I have at least two variables that I'm looking at. I'm just observing them. I'm just merely measuring them. I'm not doing anything to manipulate them. They're just a snapshot in time. And I want to study the co-relationship between those two variables, if a relationship exists at all. So I just look at those variables as they are naturally occurring. I don't do anything to them. I'm not controlling any circumstances. I'm just gathering data. So correlational research never manipulates. It never has different groups. It never breaks people into groups. It is purely looking at gathering the same information from every single person in the study and just capturing data from one single point in time. The sad correlational research is common, but it's limited. It does not let us say that X causes Y. I can't say age causes difference in social justice views. I don't know what's wrong with me. I can't make that statement. And for anyone that's been at a protest or a rally, you can see there's older individuals there too. Shit, there's people holding signs that are like, you know, I'm tired of fighting for this shit. I thought we handled this 40 years ago or 60 years ago. And no, you know, they didn't. So in their lifetime, they're going through two major civil rights movements. And so because of that, you know, I know that it's not just age that's influencing this. There's other things. And I did not do a study that allows me to say that age causes differences. I can say age is related to social justice views, but that's about all I can say. So it's really important to know that correlational research is not causation. Correlation is not causation. Just because two things are related does not mean that one causes the other. There's a relationship between absences and your grade in this class. Absences don't cause you to fail the class because that's the direction of the correlation, right? The more the absences, the lower the grade. Absences don't cause you to fail the class. There's people, shit, I went to lots of classes or took lots of classes in my college career where I didn't show up for classes except for exams, and I go to the exam and I get my A and I leave. And those were my favorite classes sometimes, depending upon what was happening in my life, right? So absences don't cause your grades. They can influence them though. So why can't we see its causation? Well, number one, because there could be some third variable out there causing both. Like, who knows? Maybe you had a death in the family. Maybe someone you know and love has coronavirus and your family responsibilities are higher. Maybe you're an essential worker and you're working your butt off and you don't have time to come to class, and you also don't have time to do your reading and study, and that's why you're failing. So it's not that not coming to classes is causing you to fail. It's all the other stress that you're dealing with in your life is hurting your attendance and at the same time hurting your performance and your grades. So that's what we call a third variable problem. Secondly, we don't know which one came first. You know, maybe it's the absences that are causing the poor grades. Maybe it was the poor grades causing the absences. I know I've done poorly in a class in the beginning, and so I just fell off the face of the earth and stopped going. I would discourage you from that approach in this class. I want you to, if you're struggling, I want you to reach out. You know, I'm going to host synchronous sessions where we can get together and we can cover the material. So make sure that you reach out, you take advantage of those opportunities, okay? I'm just using this for illustrative purposes, but I also at the same time want you to know how you can be a good student. Do your reading, and sometimes that might be, you know, at all odd hours because you're working. I get that you're balancing life. I'm not rigid on deadlines because of that, but make sure you don't fall off the face of the earth. Keep plugging away, okay? And I'm here to support you in any way that I can. Okay, so let's talk about the experimental method. Because when you talk about the comparison method, it can be experimental or non-experimental. And experiments are very specific types of research studies. And you have to have at least two groups you're comparing to one another. You always have to have at least two variables, one of which is an independent variable, and that's the manipulated variable that you use to distinguish between groups. And then you always have to have a measured variable, which is the dependent variable that we're looking at comparing between the two groups, right? And what we want to do is we have, let's say we have 100 people. Okay, we have our population of 13-year-old girls, and we have randomly sampled 100 13-year-old girls to participate in our study. We must randomly assign the girls. For a true experiment, you must have random assignment. So first we random sample. Sampling is the way in which we gather the sample from the population. Random assignment is looking at each participant's opportunity to be in either group. So I'm going to have one group that watches reality television like Survivor, and I'm going to have one group that watches reality television like America's Next Top Model, okay? So I'm going to take my 100 girls that I've randomly sampled, and I'm going to randomly assign them. I'm going to literally flip a coin, so each participant has an equal chance of being in either group. The groups aren't pre-formed, I'm forming them. That's control and manipulation. We'll talk about that, okay? And so I have my 100 girls, I randomly assign them, 50 go into my control group, which is going to be my Survivor reality TV, and 50 go into my experimental group, which is looking at how the modeling reality TV with fashion models influences eating behavior. And then I'm going to monitor the eating behavior of both sets of girls. And I'm going to look at, is there a difference in eating behavior based on the type of television show that they're watching? So one variable is manipulated, and that's the grouping variable or the independent variable, and that is the type of TV. And then the other variable is measured, and that is where I'm looking at the eating behavior. So we talk about in an experimental design, we talk about manipulation and control. Those are required elements of an experiment. Manipulation is when we are manipulating the variable. We're breaking it up and determining what different levels there are, what groups there are, how are we defining those groups, right? Who gets exposed to what if they're in that group. And then the other variable is a measured variable. We're just observing it and gathering data and seeing how it's changed based on our manipulation. The second part is control. There's all these other factors that could be happening in the world that could influence our outcomes. And I want to do my best to control for those differences so that I know that when I'm looking at the analysis, the only difference between my groups is in fact the manipulation, the type of television show they were watching, so that I can see if in fact that the eating behavior is influenced by this, right? So I want to control for extraneous variables. One of those is individual differences, right? Maybe I have girls with already different eating behaviors. Maybe I have some with eating pathologies even, right? So when I randomly assign them to groups and I'm flipping a coin, what's happening is I'm making sure that there's an equal chance that I'm going to have just as many people with pathological behaviors already in the control group as I do in the experimental group. So now I've controlled for those individual factors by randomly assigning them. And the data shows that when you randomly assign things, that those risks tend to balance each other out through the groups. Okay. So let's move on and talk a little bit about what we're trying to control for. We're trying to control for participant variables that are going to differ across participants, right? Let's say I'm looking at girls between the age of, let's say, 12 and 18, right? Age is going to vary between them, and so that's a participant variable. When it becomes a point of study, and I want to see how does the influence of television change across age? Now it's a participant variable. It's something of interest, but I also know that it exists out there in the universe. So as a researcher, I want to control for that, and I can do that through the random assignment. Additionally, I want to control for environmental variables, which are outside circumstances in the environment that could also be influencing, what I'm trying to study. For instance, the stress of coronavirus and a pandemic, or the stress of racial unrest and conflict and tension throughout our nation. So I want to do my best to make sure that, hey, I measured this group. I was looking at their eating behavior and then this huge traumatic thing happened where we watched a life taken on television with, a firm recognition that there are social injustices and racial bias in our policing system. And now I'm going to study these guys, and it's like, hold on, we just had a major traumatic thing happen that may have influenced what I'm measuring, So we have to be careful. Like if I'm studying depression, or I'm studying alertness, or I'm studying memory, and I'm giving one a test in the morning and one a test at night, or one a test in a bright, airy room and one a test in a dark, gloomy room, it could be those environmental factors influencing the outcome rather than my independent variable that I'm exploring. So as researchers, we need to make sure we're doing our best to control for those outside factors that could possibly influence our results. So the ways that I try to control for things is random assignment. I absolutely want to make sure that each person has an equal chance of being assigned to the conditions that I've created through manipulating my IV. And I can literally flip a coin. There's also online random assignment generators. You can also break up your materials in a random way, and then as participants approach you, they're randomly assigned to a group to participate in a study. So you can also do matching. This might be particularly important for variables that I can't control and manipulate. Maybe I want to study self-esteem differences in sexual assault survivors compared to non-sexual assault survivors. I can't randomly assign you to either be a sexual assault survivor or not. That's something that's already happened. It's a pre-existing condition, right? And it's something that that's often studied in psychology. We often study these pre-existing groups or fact patterns. And so what I can do is create a matched group. So I typically know that sexual assault survivors tend to be younger, female, and women of color actually are more likely to be sexually assaulted than Caucasian women. Sadly, college-age students, you're more likely to be sexually assaulted in college than any other age period in your life. I'm so sad to say that, but it's true. So when I'm matching, I have 100 women who are survivors, right? Now I'm going to match them with, if there's 95 women and 5 men, I want 95 women and 5 men in my matched group. If there's, most of them are between the ages of 21 and 24, I want to make sure that same condition is happening in my matched group. So I'm going to control for variables that will likely be factors in my outcome. Age and gender are huge self-esteem factors. And I just want you to know I'm a survivor myself. I come from a family of survivors. And so that is a particular area of interest for me in terms of research. And my education has really contributed to my strength and my ability to survive. So I'm here for you if you did ever want to talk about that, if you have your own experience. And I would say, you know, let's help use our voice of advocacy and support to raise awareness and hopefully reduce the risk to future generations of women and men. Men can be sexually assaulted as well. It's not as common, but they definitely can. Additionally, I want to hold outside variables constant. Maybe I don't want to be studying people who were severely traumatized in childhood, and in addition to being sexual assault survivors, maybe that's something I want to control for, because maybe that compounded trauma can definitely undermine self-esteem, and research shows that it can. Successive trauma over time takes a toll on you, and you can develop a sense of learned helplessness and hopelessness that unfortunately impacts your psychological health and well-being and social health and well-being. So we need to actively support our survivors. Okay. Moving on, when we are talking about experiments, when we typically use the term independent and dependent variable for all research, and we really shouldn't. Independent and dependent variable is specific to experimental studies and design. The independent variable is the variable we manipulate. We have at least 2 groups, but we can have more. And we determine, you know, that manipulation is we determine who's in what group before exposing them to the treatment. So we're controlling that temporal precedence that we couldn't control with correlational research. And there's a dependent variable, that's the measured variable. We just gather the information about it, and so we just observe that variable. So the IV is considered the causal variable. I want to see, does the IV cause a change in the DV? The DV is the effect variable, okay? And I always have 2 groups at least. And the control group is my comparison group, right? And then the experimental group is the group that receives the treatment. So I want to, if I'm looking at the effects of what type of television you're watching, survivor television, reality show is going to be my control group compared to like a fashion model show, America's Next Top Model. I want to see, does the type of show influence that? Oh, that eating behavior. Sorry, I don't know why I did that. Okay, some studies, you know, we do want to study and make comparisons and differences, but I can't randomly assign them to groups. And so I can definitely use a non-experimental method that doesn't involve random assignment. Only when I do that, I lose my ability, because I lose some control and manipulation. And so I can't always say that I can't draw causal conclusions. Experiments are the only method that allows me to say there was a cause in the DV, or a change in the DV based on the IV. So the IV caused an effect on the DV. That is the only method. If it is not an experimental method, I cannot make causal statements. So there are non-experimental methods I can use to definitely gain insight, draw conclusions, gather empirical evidence. And ultimately, lots of topics are studied from multiple perspectives, and that's the best thing. So we have a body of evidence to support our views and inform our theories and perspectives. Non-experimental methods can follow the same structure. I randomly select 100 people. I determine whether they're survivors or not survivors. And then I make those comparisons, right? That's what we call a quasi-experimental design, or a quasi-experimental variable, where they already come in pre-selected groups. Or maybe I'm looking at self-esteem across gender, comparing self-esteem between males, females, and non-binary individuals. So that's what we call a non-experimental study. When you have a non-experimental study, you can either have non-equivalent groups where they're just already pre-existing and I'm not controlling, and so I'm just comparing men and women, or I can do something like a pre and post test. Maybe I can measure their self-esteem, and then I can show them a bunch of magazines showing all these skinny people, and which is completely unrealistic. And even the skinny people aren't beautiful enough because they're still photoshopped, right? That's absurd. And that even the most beautiful people theoretically in the world are still not beautiful enough. And we put such a standard of, you know, an unreachable standard of beauty in our country, that's what contributes to a lot of our poor body image issues, just saying. Anyway, so I can measure their self-esteem and then show them a bunch of magazines and then measure their self-esteem again and see how that influenced them and impacted them. And in which case now the IV becomes, you know, it's still exposing them to that treatment, that type of magazine or fashion influence. And then the DV, what I'm comparing now is the pre-test, post-test scores, right? Okay. So I think we are wrapping up the end of this section. I just have one more concepts and then we're going to get into a learning check. So we talk about constructs in psychology and research in general, and that's just a large, abstract, hypothetical construct like love, right? So I was in a 16-year relationship, separated in 2016, still in a really ugly legal battle. But that being said, I started dating, and it's really interesting how we have different understandings of something like love, right? Even in middle age, I'm 48 years old now. How someone else defines love isn't the same as I define love. And so it's a construct. It's some hypothetical concept, and we might have similar understandings, but as researchers, we can't work on similar understandings. We need to make sure that we are on the same page. And so we operationally define how we're going to measure a variable. How do we define love? And how are we specifically going to identify it and measure it? And that's really important as researchers, because we need to be able to replicate our work and our findings. Other people need to be able to replicate our findings. So operational definitions are critical to that. If I want to study the aggression in children, and you're on the playground looking at, oh, well, you know, someone hit someone or kicked someone, but I'm also looking at someone called someone names, or someone made fun of someone or excluded someone from a play group. That's what we call social and relational aggression. Verbal aggression. You're only looking at physical aggression. So we have to be on the same page. So as researchers, we operationally define our constructs through defining how we're going to measure them, and specifically define them through observable behaviors. So your operational definition must include your operations for measurement, and it must include the definition that allows for that measurement. Okay, so again, we're reaching a learning check. I'm going to encourage you to pause, read through, write through your answers. It's going to be, again, applying what we've learned from this last section. And then when you're ready, restart and come to the answers, and we'll go through our final section. Okay, so your research study comparing alcohol use for college students in the US and Canada reports that more Canadian students drink. So they do have higher rates of their population drinking, but American students drink more. So we have higher consumption rates here in America. So this study is an example of an experiment. Why or why not? No. Can I randomly assign? What we're doing is look at your study question. What am I comparing? What groups am I comparing, right? Am I comparing groups, or am I just studying variables? And here in this case, I'm just finding out, do they live in Canada or the US? And who drinks more? I'm just measuring those things. They're reporting that to me. I'm not controlling and manipulating where they live. I'm not doing any of that, right? I could do this as a comparison, and I could just do it as a non-experimental comparison, or I could just look at, you know, where they live, and I could run it as a correlation. But the bottom line is, it's not something that, it's definitely not an experiment, because it does not include random assignment, okay? And I cannot control and manipulate where people live. What two elements are necessary for a researcher? manipulation and control. Experiments require manipulation and control, and random assignment as a means of controlling for participant variables. Additionally, this last study, Stevens, Adkins, and Kingston, conducted an experiment where participants were able to see if participants were able to tolerate more pain when they shouted their favorite swear words over and over versus when they shouted neutral words. So I'm looking at, what's the pain level between shouting neutral words and cuss words? And in my independent variable, I get to control who gets to shout what when, okay? So I can randomly assign you and say, oh, no, you can only say neutral words, golly gee, golly gee, golly gee, and you can say swear words, whatever the hell you want, right? And so I can control what group you're in. I manipulated that. I randomly assigned you. So that is, in fact, an experiment, right? I conducted an experiment. So my IV is going to be type of words, and my dependent variable is what I'm measuring, what I'm comparing between the two groups, and that's pain level. Okay, so now let's move on, and we're going to talk a little bit about some data and math. So in research, we differentiate between discrete variables and continuous variables, and discrete variables are very separate, distinctive variables, like gender. They're separate and indivisible categories. You're either one or the other or the other. You're male, female, or non-binary. Or, you know, which non-binary can include transgender individuals. It can include genderqueer. It can include gender non-conforming. Okay, I have to operationally define that, but I can't like incrementally break that down like I can with money, let's say. So they're separate and distinct categories. Or you live in Oceanside or you don't. Okay, separate and distinct. You don't live in between. You live either in the city boundaries or you don't, okay? Or you're a junior or a senior. You're not like halfway. Once you achieve so many units, you're now a senior, right? So we're talking about kind of qualitative differences quite often between groups. There's no distinctive value between the groups, but they're countable. I can count them in whole numbers. Who's in what group, okay? Continuous variables can be broken down into fractional incremental parts like height or money. They can be broken down into smaller and smaller pieces. And when you can break them down, that's a continuous variable. So when you're studying, not only do you have to look at a research question and say, what is my variable? What am I asking? What is my research question? What are my groups? How did I get them into groups? Is this an experiment or a non-experiment? Is this a correlational study or a comparison study, right? I have to not only do that, but then I have to look at the data itself and say, am I working with discrete variables or continuous variables? I also need to understand, like, when I am looking at continuous variables, they have real limits, right? At what point do I say I'm 5'9" as opposed to 5'8" or 5'10"? The boundaries for the intervals for me to be thrown into that 5'9" are what we call our real limits. So all continuous numbers, when you're talking about a continuous number line, all continuous data has a real limit. They have an upper limit, which is above the score, and a lower limit below the score. And those now, those limits are the middle point between your score and the next score. And so, you know, do I have $100 or $101? Well, there's all these things in between, but at what point does it fall into the $100 or the $99 or the $101, right? And so, you know, we think of this as rounding, but with precision. And so when we talk about our weight, I'm 150 pounds. I was maybe at one point in my life, but certainly not now after quarantine. I need to look at 150 to the nearest whole number, falls somewhere between 149 and 151. Those limits are going to determine all the people that are going to be classified as 150. Somebody that weighs 149.8 pounds, a person that weighs 151.1 pounds, they're all still considered 150, right? So the limits, if I'm rounding to the nearest half, or if I'm looking at to the nearest half, it's going to be anywhere from 159.5 to 150.5. Anything that falls in between those numbers becomes my 150. So the upper limit is the 150.5 and the lower limit is the 149.5. And I've linked you to a resource that you can use. Real limits is going to come up again. It's not something I want you to really spend too much time on, because in reality, we don't have to deal with it. SPSS will manage all of this for us, but it will come up again a little bit later when we're calculating precise medians, okay? So the other thing you have to worry about is, what type of data am I looking at? Scales of measurement. Is it nominal? Nominal, they're different in name only. They're categorical. These are discrete data. You're either in one category or the other. So gender, major, if I'm looking at, you know, do I eat, you know, am I a vegetarian or non-vegetarian, okay? Ordinal, in addition to being different in name, right, and having different categories, they rank, okay? So I might look at the who won a race, first, second, and third. There's no distinct intervals between first, second, and third, right? The distance between first and second could be a hair. Maybe first place won by just a hair, and the third place comes in a whole minute later, right? So the differences in the ranks might vary from ranking to ranking, but they're ranked. I know who came in first, second, and third. That's ordinal data. Interval data is when now not only are they different in name, not only can they be ranked, but also the differences between the ranks is consistent. So, you know, if, you know, a 5'8" and a 5'9" is the same distance as 5'9" and 5'10", or 5'8" and 5'7", that 1 inch is a distinct difference, okay? The challenge with interval data is there's no zero, there's no true zero, and we really only have temperature as a good example of that. But then some even refute that and say, no, no, there is a true zero. Those biochem majors tell me that. Well outside my pay grade, okay? So you guys go for it, you know, rule the world, get your knowledge, do you. But for mathematical purposes, interval doesn't have a true zero. And so therefore we're a little bit limited and restricted. We can't do the same with interval data as we can with ratio data. Ratio data meets all those same criteria, but only now it has a true zero, and consequently we can do ratios. I can say you're twice as tall as me, or you're twice as short as me, or twice as heavy as me. I can do those ratios, right? We'll use SPSS, which is a computer technology, and it will largely run a lot of our analyses for us. It really just groups these two together at the bottom. It calls it just scale data. Any interval or ratio data is treated the same in SPSS. It's treated as scale data. So you definitely need to be able to differentiate between them for definitional purposes, right? You know, name only, so it's just purely labels. Ranking for ordinal. Interval ranking, but distances are equal. No true zero. Ratio has a true zero, and everything else. And here's some a couple of charts if you visually want ways to differentiate between them. So here's one type of visual chart. Here's another chart that might be helpful for you as well, okay? So we're coming up to one of our last learning activities. I just want you again to pause me and then go through this learning activity for yourself, or excuse me, this learning check. So just pause me, go through, write out your answers, and let's see where you're at. Okay, so when we talk about a tax form, people are identifying their annual income, their number of dependents, and you know, you're a whole person, so that's definitely discrete. Income can be broken down into smaller incremental parts. I can break a dollar down into quarters, nickels, dimes, pennies, so that's a continuous scale. And then our social security number, you're in a category all of your own, so that's definitely discrete. Now we want to look at scales of measurement, and we want to say, okay, is that nominal, ordinal, interval, or ratio? Income, not only is different in name, can not only be ranked, it does have a true zero, and the intervals are distinct from each ranking, so that's ratio. Dependence, name, difference in name, can be ranked. You know, I can see I have more dependence than you. You can in fact have zero dependence. And so that's a ratio scale. Even though it's discrete, it can still be ratio, right? Social Security numbers, it's discrete, but it's difference in name only. There's no ranking. Your Social Security doesn't make you more valuable or higher than me, right? It might make you older than me or younger than me though, because sequentially that does matter. So maybe it should be ordinal for ranking, right? Okay, number 2. An English professor uses letter grades A, B, C, D, F to evaluate a set of student essays. What kind of scale is being used? It's really an ordinal scale. Only we treat it when we go into percentages. Right now we're talking you can have a true zero. So now when we're looking at the percentages, it can become a ratio. Okay, number 3, the teacher in a communications class asks students to identify their favorite reality TV. What type of TV show you want? It's just nominal data. It's different in name only. We might want to look at their ratings. That might be different, but when we're just looking at what type of show or what type of ice cream you eat or Coke do you like, it's just different, it's nominal. Okay, so you might want to pause me, go through these, and then turn back on the video when you're ready. Okay, here we are. A researcher studies the factors that determine the number of children that couples decide to have. I'm going to tell you, as a financial advisor for 18 years, financial security is directly related to fewer or no children, just FYI. That being said, when you look at your number of children, it is going to be discrete. You can't have half or fractional children, and it is it's also I don't know what I was saying. It's discrete. Okay, when measuring height, I am going to look at my real limits for 68, and unless otherwise specified, I'm going to look to the next ½ inch. And that's going to be anywhere from 67.5 to 68.5, the exact halfway mark between the next whole number, 68 and 69, 68 and 67. When measuring height to the nearest ½ inch, now I'm looking at I'm 68.5, right? What are the real limits? So I've got to focus on that 68.5. What are the real limits to get to the next half limit, either 68 or 69? And that's going to be halfway of 68.5. It's going to be halfway, okay, between 68.5 and 68, which is going to be halfway, is going to be 67.75. And it's going to be halfway between 68.5 and, or 68 and 68.5. And so that's going to be 68.25. Okay. Okay. We're just going to cover this last concepts. When we do statistics, we do have notation, and so you are going to learn kind of a new language, and that's okay. When we talk about X, we're talking about raw scores for the first variable that we're studying. Y is going to be the raw scores for the second variable that we're studying. So in the examples that I use, like I'm looking at your absences as my X values, and your total grades in the class, that's your Y values. When I'm looking at capital N, I'm talking about the number of people in my population, so that's a parameter. Lowercase n, I'm looking at the people and number of people in my sample, which is a statistic. I also want you to think about order of operations, and I know some of you may have learned PEMDAS. I actually teach Please Excuse My Dear Sweet Aunt Sally, because I want you to have summation built in there. Summation is that weird looking kind of E-ish symbol, and it's really important because we need to make sure that we have that sequenced properly. A lot of times when you're doing an equation and you get something wrong, it's because you did the sequencing wrong. You did it out of order. So please put this on a cheat sheet, keep this around when you're doing those little mathematical equations, keep this in front of you. Here's a little learning check just for you to kind of refresh on some of your basic math skills. So I want you to, in the first one, you just identify what do you do first based on that order of operations. And in the second group, you're actually to do some calculations. Remember, you're gonna need to look back to that order of operations. And so just go ahead and put me on pause and then restart me. When you're talking about the learning check, so over here, when I'm looking at my order of operations, please excuse my dear sweet Aunt Sally, I'm always gonna have my exponents first. So I'm gonna do the x squared first before I sum everything, okay? In the second one, it's parentheses, sum of x divided, or sum of x squared. So first I need to remember, please excuse my dear sweet Aunt Sally. So parentheses need to be done first. So the sum of x needs to be done first, and then the exponents needs to be done second. And then in the third one, I have a summation, a parenthesis, and an exponent. So first I do what's in the parenthesis, please excuse this exponents. Then I do my exponent, I square it, and then I do my summation, okay? So let's look at that in real life when I have a data set of 4, 3, 7, and 1. For the first one, it's going to be sum of x. I'm going to literally just add up all my x values, and that equals 15. The next one is sum of x squared. Again, I have to do my exponent first. So I'm going to do each of the raw scores squared first, and then sum that up, and that's 75. And then my third one, I have to do what's in the parenthesis first, please. And then I'm going to do my exponent. So first I'm going to sum up all my x's, which as above, I already saw that it was 15. Square of that is 225. Then this one, I'm going to always do my summation before subtraction. So I'm going to sum up all my x's, which was 15, minus 1 is 14. And then this other one, I'm going to do sum parenthesis x minus 1. I have to do what's in my parenthesis first. So I'm going to do all of my scores minus 1 first, and then sum all those answers up. Okay, and that's 11. And then this second to the last, it's the sum of x1, x minus 1 parenthesis exponent. So I'm going to first do my parenthesis. So 4 minus 1 first, and then squared. And that's going to give me 3 squared, 2 squared, 6 squared, and 0 squared, and that sums up to 49. And then my last one, again, I have to do what's in my parentheses first, then my exponent, then my summation. So I'm going to do first 4 minus 2 squared. That's going to be 2 squared, right? 3 minus 2 squared is 1 squared. So it's going to be 2 squared plus 1 squared plus 5 squared plus negative 1 squared. And that's going to equal 31. Okay, so any questions on that, let me know. Otherwise, I hope that chapter 1 is good reading for you. I do like this textbook. It's easy to read. So go back and actually read the chapter. And then what you're going to see, take notes. The learning checks, you'll see I ripped them right from chapter, that if you're using a newer edition, it might actually have different examples, work through those as well. And then make sure you're writing down notes for any questions, right? You're going to see lights coming on and dots connecting. And write down any questions for what's not making sense. Let's get together in those synchronous sessions and let's ask those questions. Let's work through and rumble through that together, okay? Otherwise, I will definitely look forward to seeing you guys in the synchronous session. You're going to do the odd chapters at the end of the book, regardless of what edition you have. It doesn't matter. Just go ahead and do the odd problems. Just like I have you do with our learning checks, put us on pause and then do the work and then check your answers. So the back of the book, you have the answers to the odd questions. Check your work, go back, figure out what you did wrong, and then bring questions to our synchronous session. Otherwise, I will look forward to seeing you. Have a good one.